Hey guys, so in this video where it says so in this video we're going to go over reactions of carboxylic acids, but not really just reactions. We're also going to go over forming the other carboxylic acid derivatives. So the general reaction first is what we call acyl substitution, and it's just general reaction. You have, sorry, that's a U, not a C, by the way. But you have your nucleophile, and then we know that, again, I'll keep reiterating this, right? This is slightly negative. So then we know that this carbon is positive. So if that carbon is positive, then we know negative to positive, right? And then when we get there, we get here, we get this intermediate. Again, you guys have seen this before. We want to protonate this guy here. Now, the reason why we protonate that guy first and not here, well, for one, it doesn't really matter, but this is the way Kaplan does it. So what they want you to do is, OH can't leave here, okay? Because you guys, we all know by now, OH is a bad leaving group. So if this carbonyl reformed and this happened, there would be no reaction, okay? So what's actually gonna happen is, let's erase all of that. Boop, boop. We're gonna protonate this OH here. And then after we protonate that OH, now it is a good leaving group. And what constitutes a good leaving group? Okay, let's go through that. So here we made H2O fall off, okay? And then here we would have made OH minus fall off. OH minus doesn't have a pKa, it's really basic. H2O, the pKa is about 15.7. So remember, anything below a pK of 20 is considered a good leaving group. So that's why we do that. And then you make it leave, and then bam, your nucleophile. This is pretty much every single one. We're just going to go through them. They all do the same thing, but we're going to go through what each specific one forms. So let's start with an amide. So for your amide hydrolysis, again, you don't need to know the mechanism. Like, this is the general mechanism. So for this rest of the video, we're just going to be talking, really. So again, you lose a water in the case, and then this is how you form an amide. You actually do need heat. So the reason why is, so my teacher always used to say, like, think about if you put your hand in water, right? Protein, right? Amides, proteins. When you put your hand in water, your body just doesn't start melting. So, like, to get a nitrogen to react, you need to heat it up a lot. And then another thing you need to know is your cyclic amides are called lactams. I don't know if I pronounced that right, but I'm just gonna, I don't want to spoil anything, but that may or may not be very, very important. Next, let's go to esters. So Fischer, I think this one is called Fischer esterification. This one we will show a mechanism for. So you start with your protonated carbonyl, right? And again, just like we did before, right? Oopsies. Here, that's your nucleophile. And then you only deprotonate here because we don't like oxygen with a positive charge. And then, again, like we said before, we want to make this a good leaving group. So that grabs there to go H to make that molecule. And then we go ahead and we deprotonate again. And then we have our ester. Okay. Oh no, I spelled it like the name. I have a friend. Anyways, so, and then another thing, cyclic esters are called lactams. And again, no spoilers, but okay. Anhydride. So these are relatively easy-ish. I kind of feel like anhydrides are the most intuitive. So you lose water, right? And then the water that you're losing, I think it's like these guys. Okay. And then what happens is you pretty much just form that. See, and if you look at it, it makes total sense, right? So you lose these two, and then you just make a bond between there, and then bam. Okay? Very easy. Don't overthink this one. Next is reduction. So this is reduction. You could only use LiAlH4. You cannot use NABH4. And sorry, there's so when you reduce a carboxylic acid, it turns into a primary alcohol. Okay, and then that's just like memorization. Yeah. And then last but not least, decarboxylation. It looks very hectic, and that's because it is. This one is pretty much you first off you make an enol, and then you make a carbon dioxide molecule, and then you need to remember your enols can tautomerize, and it's going to prefer your keto form. So what's pretty much happening is you're pretty much cutting your bond here. Do you see how here I did this? So that's where you broke the bond. So you put a double bond there. And all of this happens in one step, by the way. So you put your double bond there, right? But remember, this carbon can't have 5 bonds. So now that your double bond is there, these lone pairs go back to the oxygen. So that gives the oxygen 2 more lone pairs. And then those 2 lone pairs grab this hydrogen. These lone pairs fall back here, and then we recreate the double bond. I know, but it really, try to write it out and then it'll make a lot more sense. So yeah. So next video, we're going to do the derivatives. Very short video, almost done, only a few. Okay, see you guys.